In exercise 9, we're told that Sam and Jeremy have ages that are consecutive odd integers. The product of their ages is 783, and we want to know which equation can be used to find Jeremy's age if he is the younger man. We're looking for consecutive odd integers. Remember, consecutive odd integers are 2 units apart, so if we called the first one n, the next odd integer is 2 units away at n plus 2. The variable we're using in this problem is j, so we'll use j and j plus 2. We're told that the product of their ages is 783. A product is multiplication. If we take the age of each of the boys, j times j plus 2, that product equals 783. Distribute, and we have j squared plus 2j equals 783. Look at the choices carefully and identify the correct solution. Choice 3 is the answer. In exercise 10, we're told that a population that initially has 20 birds approximately doubles every 10 years. Which graph represents this population growth? Remember, if something is doubling, it means that we're multiplying by 2. That's important. If we have repeated addition, we have a linear function. If we have repeated multiplication, we have an exponential function. Because we're multiplying by 2, we have an exponential function. Looking at the graphs, we can instantly eliminate choice 4 because that's a linear function. If the population is doubling, it means that it's increasing. If we look at the graphs, we see that 2 of them are increasing and 1 of them is decreasing. Choice 2 is out. The population is increasing, and so it can't possibly be choice 2. Next, we're told that the initial value was 20 birds. That's the y-intercept. Look at choice 1 and choice 3 carefully. Which one has an initial value, or a y-intercept of 20? Choice 3 does, and so choice 3 is our answer. In exercise 11, we're told that we have a function, f of x equals 2x minus 4, and it's defined over the domain with x being between 2 and 6 inclusive. Let's look at a graph. Here's the graph of the function f of x equals 2x minus 4. They say that the domain is from 2 to 6, and so we're interested in x values starting at 2 and ending at 6. What is the range? Range is the outputs, low to high. If we look at the region in the red box, that's the domain from 2 to 6, notice the lowest y value, the lowest output, is 0, and the highest output is 8. That means that our range is from 0 to 8. We include 0 and we include 8 because those are the values at x equals 2 and x equals 6, and those x values are included in the domain. So the range is from 0 to 8. We can write that either using inequalities or using interval notation. Choice 1 is the answer. Another way we could do this is we could look at a table of values. If we put the function f of x equals 2x minus 4 in the graphing calculator, and we go where x is 2 and where x is 6, we see that the lowest y value is 0, and the highest y value is 8. The other y values between there all fall between 0 and 8. And so once again, we can conclude that the range is from 0 to 8. Again, choice 1. In exercise 12, we're asked which situation could be modeled using a linear function. It's important that we know the kinds of things that are linear and the kinds of things that behave in an exponential manner. Choice 1 talks about the value of an account increasing at a rate of 5% annually. If something increases at a percentage rate over and over and over, we have exponential growth. So choice 1 is exponential. Option 2 talks about the population of bacteria doubling every 4.5 hours. If something doubles, we're multiplying by 2, multiplying over and over and over. When we multiply, that's exponential. And so choice 2 is represented by an exponential function. In choice 3, we're told that the cost of a cell phone service that charges a base amount plus 20 cents per minute is another option. We have a base amount plus 20 cents for each minute. That's repeated addition. When we add repeatedly, we have a linear function. Choice 3 is linear. Option 4 says the concentration of medicine in a person's body decays by a factor of 1/3 every hour. If it decays by a factor of 1/3, it means that we're multiplying by 1/3 repeatedly. Repeated multiplication is an exponential function. Which situation can be modeled by using a linear function? Choice 3, the cost of the cell phone service. Problem 13 asks which graph shows a line where each value of y is 3 more than half of x, and we're given 4 graphs to choose from. There's a couple of different ways we could approach this. The first is to think algebraically. Y is 3 more than half of x. We can write an equation where y equals 1/2 x plus 3, half of x plus 3 more. Which graph matches this? We have a slope of 1/2 and a y-intercept of 3. Look at the graphs carefully, and we see that choice 2 has a y-intercept of 3 and a slope of positive 1/2. Choice 2 is our answer. Another way we could do this is we could create a table of values where each y value is 3 more than half of x. Pick a variety of numbers for x to be. Since we're going to take half of it, let's make them even numbers. We'll pick some positive numbers, 0, and we'll put a negative number in 2 to see what happens. If we take each number and we cut it in half and we add 3, we get corresponding y values. Look at the graphs and identify which one matches the table. We notice that the points given are found on graph 2, and so again, choice 2 is the answer. In problem 14, we're given the table which shows the average diameter of a pupil in a person's eye as he or she grows older. We want the average rate of change in millimeters per year of a person's pupil diameter from age 2 to 80. Average rate of change is found by using the slope formula, y2 minus y1 over x2 minus x1. We want the average rate of change from a person aged 20 to a person aged 80. We identify those values in the table, and we write down those points. We substitute them into the formula and work carefully. We find that the value is negative 0.04. The average rate of change is negative 0.04, or choice 4. In exercise 15, we're given an expression, and we're asked which of the choices is equivalent. There are several ways you could approach this problem. Option 1 would be to factor. This is a quadratic form trinomial, and so we can split the middle. We want numbers that multiply to 36 and add to negative 12. That's negative 6 and negative 6. We do the substitution, and then we factor each half of the expression. We end up with x squared minus 6 times x squared minus 6. Choice 1 is the equivalent expression. Another option for factoring is to use the grid. We place the x to the 4th in the upper left-hand box and the plus 36 in the lower right-hand box. We use the minus 6 and the minus 6 to replace our negative 12x squared. Because the original term was x squared, we'll attach an x squared to each of those numbers. Now we factor the greatest common factor across the top. The greatest common factor of x to the 4th and minus 6x squared is x squared. Use multiplication to fill in the rest of the positions. X squared times something is x to the 4th. That's x squared times x squared. X squared times something is negative 6x squared. That's x squared times negative 6. And now we'll multiply down. X squared times something is negative 6x squared. That's x squared times negative 6. We now have our two factors, x squared minus 6 and x squared minus 6. Again, choice 1 is the equivalent expression. But suppose you don't recall how to factor, and you need to find the solution to this problem. Well, there's another option, although it's a little more time-consuming. You could take each of the choices, write them out, and multiply. Remember, you have to use the distributive property to do this, and then combine like terms. When we multiply them out, we find that choice 1 is x to the fourth minus 12x squared plus 36, which matches the original trinomial that was given. And so again, choice 1 is our answer. There's one more way we could approach this. We could set each one y equals, and then look at the graph and the table to determine which one was the same. If we look at the table for y equals x to the fourth minus 12x squared plus 36, and then we look at a table of values for each of the choices, we notice that the table given in choice number 1 matches the table from the original. That means that the two expressions are equivalent. And so choice 1 is once again the answer. In problem 16, we have an arithmetic sequence. Remember, an arithmetic sequence is a sequence that's characterized by repeated addition. We want to write an equation that can be used to find any term in the sequence. There are a couple of different ways we can do this. Let's take a look at these options. Let's see what the sequence looks like. The third term is 10, and the fifth term is 26. To go from 10 to 26, we added some number twice. Let's call that number n. What is the common difference? Well, 10 plus 2n gave me 26. The number that we added each time was 8, and so the common difference is 8. We can use that common difference to fill in the blanks. 10 plus 8 is 18, and 18 plus 8 gave me 26. Now let's go backwards. 2 plus 8 gave me 10, so the second term must be 2. And what did I add to 8 to get 2? Well, negative 6. Now I have my first term and my common difference, so I can use my formula. an equals a1, the first term, plus the common difference, d, times n minus 1. First term is negative 6, common difference is 8. Distribute the 8, combine like terms, and we see that the equation is an equals 8n minus 14. Choice 2. Another option to solve this would be to look at the table of values for each of the given equations. We have our arithmetic sequence with our third term of 10 and our fifth term of 26. Take each of those equations, put them in your graphing calculator, and look at the table of values. Which one has a third term of 10 and a fifth term of 26? On close inspection of the tables, I see that the table for choice number 2 is the one that has those terms. And in fact, I recognize the first term, second term, and fourth term from the work I did earlier. So the answer is choice 2.